Hello, everyone. Can you hear me? Can you hear me? Okay.
Yes,
Yes.
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 Good evening to everyone. So we are going into module number 5, which is hypothesis testing. And what is the purpose of hypothesis testing and what is the process? I'm briefly going to explain today. So let me start with whiteboard. Ca- Can you see my whiteboard?
Yes.
Okay. So hypothesis testing is basically based on mean, standard deviation, proportion, variance, standard deviation or variance. So these are the things we assume and we test whether our assumption is correct or not. So hypothesis is nothing but assumption or a statement that you make and that you prove using data and statistics. So today, let's say I'm saying that in my neighborhood the housing price will be about $500,000. Average home price is about $500,000. So this is my statement or hypothesis, I would say. I just assumed and I just guess, but I don't know it is correct or not. But you are saying, no, professor, you are wrong. This is not. Probably the area will be more than 5,000 or less than 5,000 or different. We have argument with each other. I mean, you are saying, no, I'm correct. I'm saying, I'm correct. How that can be proved who is correct? So basically, this is a statement or hypothesis that you make. Then you go through the process of testing whether this statement or uh, this sentence is correct or not. So basically, this is like I said, average home price. So basically, this is like a mean. Same thing I say the proportion in this neighborhood would be 50% male or 50% female or something else I can make, so that will be based on proportion. And similarly, I can say about variance. So let's start with simplest mean. There is also hypothesis testing based on different other things, but in this module, we are just going to discuss about this. So first, a statement, then we decided, okay, let's do. The second thing is to at what level of confidence do we need to check this statement. Let's say we decided 95% confidence level or 95% confidence interval. So this is, and alpha is 5%. So automatically this is called significance level. Significance level is 5% and confidence. So basically, if you see this graph, if this is confidence interval, this between this, then remaining this or this is significance level. So confidence level, if you know significance level, you can understand confidence, and confidence, you can understand significance. So we are going to check our statement on 95% confidence. Okay, by default, this is the value. Then third step is, let's say, collect the data. We have to get the sample. So let's say I collect a data of a sample of uh, 60 houses in my area, and I check the value from, let's say, Zillow.com or Realtor.com or Rediff.com. Redfin.com, different .coms, and I check the values of home recently sold or on sale. Okay, I collected these numbers. Then fourth step, I calculate the Z value, T value, I calculate the T value. Statistic, basically that is called calculate the statistics value. Fifth, compare with table value, or here you say instead of comparing, you can based on P value also you can do this. So compare with sixth step, accept or reject your null hypothesis. And step, make your decision. Accept or reject, reject. And seventh, make your decision. Okay, you are correct or I am correct. But before here, confidence level, we have to form null hypothesis. Very first step is to write null hypothesis and alternative hypothesis. So confidence level, before confidence level. So first step is formulating hypothesis. So there are two types of hypothesis. Technically you need to always write null hypothesis, which is called H0. Always this is a and then colon. So mu is equal to 500K. So basically this is my hypothesis, null hypothesis. I'm saying mu is with an and alternative says HA. Sometimes some authors write or someone write also H1, or I can write H1 or HA, and which is opposite mu not equal to 500K. So first step is writing the null hypothesis and alternative hypothesis. Second step is making your alpha level, significance level, or confidence level. Third is collecting data and keep going. So this is very simple process of doing hypothesis testing, and which is clearly given in the slide if you follow. Now let me show you this practical in Minitab. So let me go under share. Okay, so this is my Minitab, and let's say here I am just South Hill Spokane. So home value. So I'm just what I'm going to do, I'm going to enter the random data here using random calculator. So I go under this random data and I go under integers, sorry, calculate random data integer. Okay, here. And number of rows, let's say I'm going to collect 60 home data. So number of rows is this, and I'm going to insert in this. Minimum house value would be like, what would be, do you think? Okay, I see 400,000 is the minimum value in my area, 400,000. Maximum value is very high, but roughly I'm just saying 750,000. So these are the houses. So I just put here. And for example, this is the data I collected from Zillow or Realtor website. And I have 60 houses data of their price. Now I go under statistics, basic statistics. Can you see my Minitab?
Yes, we can.
Okay. And then I go under one sample T, one sample. Why we are using? Because I don't know the entire spoken standard deviation of housing prices. So I'm using one sample T, and I can have summarize, but I'm using this. So now this is data. Now, like I said, hypothesis value, I said 500,000. So this is 500,000. Okay, correct zeros. Now here you see 95%. So alternate, Minitab gives you alternative hypothesis always. Minitab doesn't have null hypothesis. It always gives. So what is our hypothesis? Mu equal to 500,000, mu not equal to. So basically I'm selecting, we have two other options we'll talk about. So 95%, and now we go to, so our job is done, hypothesis testing. Now we have to interpret the result. So you can see the null hypothesis is mu equal to 500,000. Alternative is uh, not equal to 500,000, and t value is 3.92, p value is 0. Mean is, average is whatever data we collected. It's a 552,000, standard deviation 102,000, this confidence. So you know all these numbers and its meaning. We have to check our value here. So if mu equal to 500,000, t value is 3.92. What is the meaning? So let's see what is the t value of n equal to 60, means what is the exact value of n equal to 60. Then we compare. So this is the calculated or statistics value. Let's check about uh, table value. So I go under graph, I go under distribution, I go here, I check the t distribution, and degree of freedom is 59 because we have 60 data points and we would like to get 5% here. And you can see what is the value, minus 2.0012 to 2.001. So basically this is the table value or theoretical value, and this is the calculated value 3.92. So where our t value is coming? So if I take the, so basically 3 point something is coming, 3 point whatever, it is coming after this in red area, which is not coming within this region. So suppose our t value comes, let's say for a minute, t value that is 1.96, which is within this range, -2 to +2, then our null hypothesis is accepted. But our t value is coming 3 point something, which is in rejection region. Therefore, we will say null hypothesis. In simple meaning, I'm telling null hypothesis is rejected, alternative hypothesis is accepted, and we say what is proved? Mu is not equal to 500K. So this hypothesis has been proved that it is not equal to 500,000. If suppose t value is coming is 1.96, then I can say, so this is the process. In this, there are two types of possible error, which is called alpha error and beta error, or type 1 error and type 2 error. And when those things are possible, so I'm not, because that becomes another topic, which is power curve and all. So I'm not explaining those, but I'm explaining in brief what is the significance and meaning of alpha and beta error. So let me explain those things. So let's say you calculated the value and t value is coming 2.05. Okay, 2. It is coming, for example, 2. But this value is, or 2.01. Let's say this. This is the t value coming. Means very close to this cutoff point or borderline. Then what could be the possibility that you can accept this hypothesis and reject? It might be due to it might be due to your wrong perception of selecting the confidence interval. If you change the confidence interval little bit, let's say you selected 95 instead of 95.5, if you select this confidence level, this value will be within this range. So one is due to confidence interval. One could be the x value that you have selected, or mu value that you have selected. Instead of 500K, let's say you selected 550K, or whenever it is boundary condition, then this hypothesis might be accepted. So in both case, because we select from 95, the hypothesis could be accepted in 95.5 or 95.105 or something. Or instead of 500,000, if hypothesis can be accepted at 510,000. So these assumptions that we made, or we based on that we can assume errors, and that those errors could be, and we can get to know all things when we learn about power curve that we are skipping in this module. So here, type 1 and type 2 error. What is the meaning of type 1 and type 2 then? So if H0 is true and reject H0. So basically H0 is true, H0 is false, reject H0, fail to reject H0. If H0 is true, but you reject because probably you selected little bit confidence level or little bit, this occur with the probability of alpha. Means you select probability of alpha 5% to, it could be 4.9%, it could be 4.5. So type 1 error could be, if you change little bit alpha value, your hypothesis can be accepted and rejected. This is due to, and type beta, type 2 error, H0 is false, but you fail to reject because your mean value, that, the hypothetical value you selected little bit. So this has happened due to this. This occurs with probability of B. So basically this can be, if you want to learn more detailed about this, you can get into the book and learn about beta power and alpha power and power, that is called power curve, and that will be another lecture. So this is a process. Now let's go into the, so basically based on t value, what happened, what is our conclusion? uh, so based on this t value, another way to, instead of going into t value, you can decide based on p value. Remember the rule of thumb. Rule of thumb: if p value is less than alpha value, then reject null hypothesis. Reject null hypothesis H0.
Professor,
P-value,
is that, sorry, is
yeah,
that rule always apply for all the tails, including left, right, and both tails?
always applicable when you know, not only in this hypothesis testing, you know, there is a regression, other things. Always this is there. So we by default you know, alpha is 5% here. So here p-value is coming 0. 0 is less than 0.05. So we reject the null hypothesis and we accept the alternative hypothesis. Let's say I'm going to demonstrate the same thing. I'm going to change little bit mu value. Instead of 500,000, let's say I change my statement. I said the average price is 550,000. And let's see how it works. So uh, statistics, basic. I hope you are able to see my Minitab. And here I just change instead of 550. And now you see. Now what do you conclude? I have not changed in, you know, I changed the mean price and our null hypothesis is accepted because you see the t value is 0.16 and this is t distribution. So it is coming within acceptance region. P value is also greater than 5%. So our null hypothesis is accepted. Let's say same thing I do, you know, in previous case I did. I'm going to do one more thing so that you can understand how. Here I did, let me do 500,000 again. And let me do, instead of 95%, let me do 99%. And see. At 99%, this is also failed. The hypothesis, this is. So basically, selecting the correct mu value or hypothesis value, it should not be like randomly you can say the housing price. You need to have some understanding, something, some rough estimate about that. Means you can't say the average house price is $1 million. Or when you go to Beverly Hills, you can't say the average house price is 300,000. So it should be close, and then you can test who is correct and who is. So let me see, and I can do here. Let's see what I 525, and I excuse me. Let's say 97.5. So basically, yet I did something wrong, probably. So you can test, and see at what level your hypothesis is correct. So you see the p-value. You see the p-value. So p-value is also decision-making factor that, at what level of significance this is. So if p-value, this is always, remember, if p-value is less than alpha value, then always alternative hypothesis is correct. You reject the null hypothesis. But in this case, your null hypothesis is true, which is 550,000 is correct. Average house price with 95%, I can say I'm 95% confident that average housing price in my neighborhood is about $550,000. So this is same thing you can do. So basically here, again, if you remember the past week and basic, when do we use z-test? I can use z-test If I know population standard deviation, if I know the entire South Hill area in Spokane and the standard deviation of the housing price in this area, let's say 50,000, then I can use z-test. Otherwise, I can use t-test. So one sample z, one sample t, one proportion. Exactly, if you remember, the same thing you can do here. And you can do the proportion 50%, 40%. You can select approximation when you need to use normal approximation n pi equal to 10 greater than equal to 10. If you remember that condition, n 1 minus pi. So if you follow that, when do you use normal approximation? When do you use exact? So the same situation in one sample. Similarly, one variance and same situation. So basically mean, proportion, and standard deviation or variance, you can compare. You can assume the standard deviation of housing price in my area would be like 50,000. Then do the analysis, just collect the house price and do it. So for example, I'm just variance, let's say 50,000. So I just select this and hypothesize I selected $50,000 is the difference, 50,000. And again, the same 95 by default. And here you get two values, which is not correct, p value. So sigma square is variance, 50,000 and 50,000. No, this is not correct. So this is what statistics, basic. And one sample z, one sample t, one proportion, one variance. We are dealing with these four options in this week. Okay. Now what else? So critical values you can get directly from the, even you can do all these things in, how do you calculate the t value? So basically you have to calculate the mean, hypothesized mean, standard deviation of the sample. So basically, how do you calculate this what we did in Minitab? So let's say we did this here, t value 3.92. How you can do in Excel? T calculate equal to x bar, which is mean, average hypothetical value like 500,000, 550, standard deviation of that sample that you collected, and square root of n, means 60, 50, whatever sample you have, and you can do that. So this is, we are not covering the power test, and so this is module number 5. Now I'm open for your questions and comments.
Hi, Professor, this is TT. I have a question.
Please go ahead, TT.
So in the book, under the unknown standard deviation, so we have to use the t value. However, there is a section, it's called large samples.
Mhm.
Then we're gonna be using the z calc instead of a t calc. So
Yeah.
what
So-
exactly is that large samples? What size are we thinking? Are they
So
thinking?
if you look into the t distribution table, have you had a chance to look into the book?
Yeah,
After 30,
150 was
yeah,
the
that
maximum.
z, but that case you need to have the population standard deviation. So let's say if you are dealing with this and you are dealing with this, let's say this is okay. I have, for example, here 60. And let's go into this. Do I have the standard deviation known of the population? Because standard deviation of the population is known, then only you go ahead and do this. Or
Right.
yeah, z value, when you compare the t value, so basically we can't do here, but you can use the t value like critical values of z table when your sample is large enough. Let's say, for example, just let's say 150 sample you have. So I show you probability distribution, and let's say, I hope you are able to see my mini tab. So let's say t distribution, and I'm taking like 150 sample size, and I'm just saying 5%, and let's see, this is the t distribution 1.976 and 1.976. This is the same thing I'm going to do for normal distribution, and we can compare right here and normal, and I can do it for 5%, and okay. So now you see 1.96, this is a normal distribution. I mean, always 95% is always plus minus 1.96. But when you see the t distribution, it's a 1.976, which is very close to this. So this is the meaning that after, like 30 plus numbers, you don't need to look into the table of t or anything. You just remember 1.96, 2 point something, three values, 90%, 95% of these numbers, and you can make your decision.
So after 30, we could use
So
Z if
after 31, sample is 31, so degree of freedom is 30. Basically, that is what most author says. But if I would suggest, if you have sophisticated tools like this, I would suggest to use proper tool and check that, because 1.96 and 1.976, there's a very slight difference. And if you have this tool, probably use the thing. That was the situation when we don't have the table. I tell you why this has happened. So just a minute, let me show you the issue that uh, t distribution, and this is the situation I faced in my life, because our time we used to get only this printed table in our exam or everywhere, and that, so this is a bigger table. We used to get up to 30 only, and after that 30 or something is the value, infinite value is given. So look into this. We have t value uh, of these of degree of freedom, and 5% to all the percent, and we used to have 30, after 30, 40, 60, 80, 100. We used to get this table, and suppose we have 70 sample or 80 sample or 110 sample or 45 sample, how we can get do the calculation? So our professor and our instructor and our books and all suggest, after, if n is more than sufficient, you can assume the z value. So it was a limitation that time. Now you have all the sophisticated tools, Minitab, Excel, calculators, all. So use the exact value if you can do. But because of this, z value is considered, because after 31, you see this is the 30.683. you see 0.683, this is 0.674, very close to,
Got it.
so is it clear, TT?
Yep. Thank you.
You're welcome. Any other questions? So hope you understand what is the importance of hypothesis testing. This is just a beginning. We have different hypotheses for different purpose. This is just mean, proportion, and variance to compare your hypothetical situation with the real data, calculate. So these are the steps in order to do hypothesis testing. So always follow these 5-6 steps. Few authors gave 5 steps, few gave 6 steps, few have, so this is, so these are the steps.
So did you say that we're not going to cover the power curves
No, we
in
are,
the book?
because power curve is another complex situation to deal with. So many students, and this course is prerequisite. If somebody is interested to learn that, they can learn, because but practically many students are having challenges dealing with this subject. So that is next level of complexity, and I don't want to give much
Okay.
complexity.
But another optional section in the book is called test for one variance, which you just cover, and that it's going to be covered in our lectures, right? That's going to be in our exams or quizzes.
No, in exam also we will not cover the power curve and power.
The one variance, I'm talking about the one variance.
Yeah, one variance and one proportion and one sample.
Okay. Thank you.
You're welcome. So we will be covering in exam till module number 5, means including this module. Next module we will not cover. That will be just to cover and I would like to take a next class earlier. I mean, before starting next week. So will you be available on Saturday or Friday evening? So I can explain module number 6 because following Saturday we will end the course. So you will have sufficient time. So basically my purpose is to take module number 6 class within this week.
Raj, what time are you thinking?
Same time, because most of the students free by 6 o'clock. So I start at 6:10. So Friday 6:10 or Saturday 6:10, or Sunday, I don't want to disturb anyone, or Monday we can do on Monday 6:10 latest, because Saturday we finish everything. So Monday is fine with everyone.
Monday would be better, I think.
And
than
what would we
Saturday,
be
so
doing
we have
Monday?
more time to.
Module number 6,
Okay.
or
Yeah,
I mean,
I think Monday's good. I think that would
Monday.
be fine.
okay, fine then, because module 6 we will not cover in the exam, but you need to do the assignment by Saturday. We don't have the next Monday. By Saturday, everything will be end. Next Saturday, which is 10th, I think. So I will make the announcement very clearly that we will not have any extra day, because still I get some mails that I don't expect at MBA level. Student forget and other things. So okay, let me make the announcement, and please be ready by 10th of February. You are going to finish everything. Any question, please feel free to ask.
So we'll meet Monday the 5th at 6 p.m. or 6:10.
6:10, yeah, 6:10.
Okay.
Okay, so Elisa, you are asking one variance and one proportion again when. Okay, so one proportion, let's say, Okay, so I'm just going to demonstrate when do we use proportion. So when do we use proportion? If you remember, Elisa, binomial distribution, binomial proportion, let's say you have two situation, yes, no, or proportion situation. Let's say I go and statistics, and I decide all the students who are coming to from India to US, like I gave the example that 52% of students based on the sample. So there's research university and non-research university. So I have a data of everyone, and based on that, I would like to assume that, okay, all the students coming, 60% will be taking admission in research university. So I go, and if I want to make my statement correct or not, I have to check the hypothesis testing. So I go under one proportion, and the same process, 95%, I have to collect the data of my sample. Let's say 50 or 60 or 70 students I collected, or let's say number of trials I did 500, and out of that I got like 256 something. Our research university, then I said 60%, so 0.6, and by default 90%, and then I test the hypothesis. And then I get the z value and I get the p value. So what my p value says, that no, 60% is not correct. All the students who are coming, their proportion will not be 60% in research university. So this is the proportion situation. Let's say, Elisa, is it making sense? Similarly, variance, let's say, variance is very simple to explain here. So this is like house prices, and the standard deviation and house. So standard deviation and variance, the relationship in standard deviation. So sigma square is variance and sigma is standard deviation. So I go under this, and I assume here I was claiming that 500,000 is mean average price of my neighborhood. Now I'm claiming that variance in housing prices would be about 50,000. Variance of housing prices will be about 50,000. And you understand, so I go under statistics, I go under basic statistics, I go under same one variance, and I collect it. So variance and standard deviation, both options are given. So I select the variance and I select the data, and so null hypothesis, alternative hypothesis, variance is 50,000, not, and p value suggests variance is not 50,000. Is it making sense, Alisa? Okay, so this is the situation. And now one more thing I would like to share, because it is skipped from my mind. So basic statistics, one sample T. Now here you see we did 525,000. Let me do the 550. Oh, I think I put extra zero in that, therefore it was not. So here now you have two more options. One is this. One is mean is less than hypothesized mean. Means alternative. So basically, alternative hypothesis would be Mean would be equal to or greater than hypothesized mean. Here is this. So mean is greater than, so let's say so you can read this mu equal to 550,000. Mu alternative is more than 550,000. It says what it says. No, alternative is not correct. Null is. So if you see the slides, basically in this case the alternative is written like this: equal to and this less than. So basically two symbols are used: less than or equal to, and alternative is greater than. Similarly, if you look into the second option, statistics basic, one sample, and now we do the third one, and here you see. So look into this, and here p-value. So this is mu equal or greater than, and this is less than. So p-value is coming, which is equal to, or this case. This is cancel. So basically, now we check. So basically, this is the meaning. When you look into the slides, there are two options when you see the greater than or equal to or less than. Less than or equal to and greater than. So basically, this is the so you need to select correct option when you select which hypothesis you are testing. This is option only alternative. It is not null hypothesis. It only gives alternative option. Okay. So this is about this peak, and any question?
Professor, I have a couple more questions. So, the t value on there, that's the t test statistic, and also when it shows the z value, it's also that's the test statistic value that is talking about, right? It's the t calc and the z calc. Is that right?
Yes. Yes.
Okay. The second question about the proportion. So the rule, the n times the pi greater than or equal to 10, is that applied to proportion only, or does it apply to the other tests as well?
I mean, to be honest, I don't get what is your question? Can you repeat it, please?
So the rule of thumb is n times pi greater than or equal to 10, or n times 1 minus
Okay, so
pi.
this is only in proportion case, and you know
Okay.
we have been studying in previous chapter also. When do
Yeah.
you consider the normalization?
Right.
Normal situation, normal distribution. So basically, we are testing here the z value. So look into this. I think we did, and so
But that's only applied to the proportion rule only, right? Not
yeah,
anything else.
exactly. Yes. So look into this. So here, option, here we have exact. Now I change the exact. I am not changing. So we will get only, look into this. We will get only p value. We don't get the z value. Z value is normal distribution. Z value, it is standard normal distribution. We don't get z value here. When do we get? And look into the same situation here when we use the normal approximation, because that is normal, then you get the normal distribution value. So here you see now you get z value.
I see. Thank you.
You're welcome. So if you don't have a question, I would like to say wonderful evening. Have a productive week ahead and good night and see you next Monday.
Thank you.
Thanks, Raj.
Thank you.
Thank you.
Thank you.
Have a good night.
Bye bye. Good night.
Thank you.
Thank you.